Hello, my name is Erik Jagnandan. Welcome to Lab. So the central purpose of this lab was to generate models in Blender and export them into a world in Unity. And that's exactly what I did, as seen with the baseball bat. So to create this baseball bat, I used 3 different cylinders, added chamfers to make smooth transitions between the surfaces with different circumferences. And then I added image textures and normal maps as seen here in the shader editor. And I did this not only with this one baseball bat, but with a total of 7 different models for the baseball bat, a car, a helicopter, a chair, a table, a traffic cone, and a trash can lid. So then I took all these models and exported them into Unity and seen in my Unity world here. And you can see down here, we have the cone, the baseball bat, cone, baseball bat, trash can lid, chair, table. Over here is the car. And then all the way up here is the helicopter. So then I implemented the first-person controller, which I did by going to the Unity store, downloading the standard assets and importing them to this project. And then I added the main camera, player follow camera, and player capsule to the world such that they could play in the first person. Moreover, I added some lighting to my scene. And I did this not only by using point lights, which are seen in all of these street lights going up and down the street. Each one of these lampposts has a light bulb object which has a point light within it, and that's providing the lighting along the sides of the street. But also my skybox, which you'll see in a moment, has a very bright, beautiful moon, but it doesn't actually generate light in the Unity scene. So what I did is I actually created generated a directional light in line with the moon, which provided light coming down into the scene to simulate moonlight, since it wasn't actually produced by my skybox. Those were the 2 roles lighting played in my scene: point lights along the street, and then a directional light simulating moonlight. Moreover, you'll be able to see, especially once you get into the first-person control, that everything, not only were my Blender models. Not only did my Blender models have image textures and normal maps, but so did everything just generated directly in the Unity scene. You can see that on the buildings with the brick texture and the window texture. You can see this on the ground with the asphalt and sidewalk textures. You can see that, especially now that we're in the first person, you can see all of these things, as well as a little bit on the lamppost as well, but they're a little more subtle because that's supposed to be metal. So yeah, you can see these textures here on the buildings, on the ground, even on some movable objects, which I created directly in Unity in the soccer ball and crate. As well, you can see the lighting provided up and down the street by these lampposts. And also you can see the moon up there in the skybox doesn't literally create light, but I added this directional light, which creates the effect of moonlight, which you can see by these buildings here being especially bright, lit up by the directional light simulating moonlight. So you can see the first-person controller is able to move around and jump. And you can see that I've included scripts in my work as well, as the car moves forward and backward, and the helicopter moves in a square pattern. And it's a repeating pattern for both. So I wrote a script called carmovement.cs for the car and helicoptermovement.cs for the helicopter, which we'll be able to see in a moment once we exit first-person controller. I also added rigid bodies and physics to my scene. So all of the movable objects, mainly the objects created in Blender, had to have rigid body components applied to them and realistic physics. So you can see that here, that when we run into these objects, they move and react in ways consistent with how they should in real life. They're not phasing through the ground. They fall and roll around, but do so realistically. If you see this falls to the ground, falls in a normal manner. Nothing's falling all the way through the floor. And then we also have 3D audio. And you may not be able to hear this on the audio recording, but if you go into the virtual world, you will be. That when you get closer to an object, its associated audio becomes much louder. And exiting first-person control now, you can see that this was done by applying to the helicopter and the car, the 2 objects with 3D audio, an audio source component. And on that audio source component, the spatial blend aspect was set all the way to 3D, making the audio 3D in the sense that as the object moves further away, its sound level dissipates and gets lower and lower. So this was done not only for the helicopter, but also for the car. So you can check on that in a moment once Unity is done loading. Furthermore, we'll also see the scripts which allow the helicopter and the car to move as they did, as we saw them through first-person control. So in helicopter, we can see we've got the audio source with 3D spatial blend, as well as for the car, we have an audio source of 3D spatial blend. Now we can look at the scripts that allow these to move. So here's the car movement script. It may take a little bit for for VS Code to load up. But once we get there, we'll see the code, which is allowing the car to move forward and backward. And then later we can look at helicopter movement.cs, which allows the helicopter to move in its square pattern. So Visual Studio is getting fired up now. And now once we're in Visual Studio, we now see that our code, which I wrote for car movement.cs, it tracks, first of all, it keeps track of the direction which the car is moving with this variable here, direction. If it's moving forward, we move times positive speed. If it's moving backward, we move times negative speed. Next, we can look at after movement code, which is a little more complex, not just merely moving forward and backward, but rather in a more complex square pattern. So we'll go to the helicopter, look at its script. Once Visual Studio is all up and ready. So here we're about to look at helicopter movement.cs, in which we see that rather than having 2 directions of movement, we now have 4. So we have to keep track of direction through directions 0, 1, 2, and 3. If we're moving forward, move forward times positive speed. If we're moving backward, do forward times negative speed. And we can move left and right as well now because we're in the square pattern. So that concludes my presentation, VR Lab Lab 4, where I took generated models in Blender, exported them to Unity, and put them into a scene in which the player can access the scene and play in it through first-person control and a first-person camera, along with solid lighting, normal maps, scripting, 3D audio, and rigid bodies which obey the laws of physics realistically. So thank you very much for your attention.